Hi, everybody, and welcome. Today, we're going to be starting off with our review of solving equations, linear equations to be more specific. What you're going to notice today is that there are going to be a few skills and a few vocab definitions that we're going to be covering. So I just want to name before we start that on a typical day, if we're learning some new material, we're only going to be seeing one skill at a time and one vocab word. But with it being a little bit of a review, we're going to be doing a couple of things at once here. So what I will say is if you're feeling really confident with this material, that is awesome. Think of yourself in the role of someone that can help support other friends that maybe need that extra support now. Know that maybe later on you'll need that support too. And if you're having a hard time, reach out to me, reach out to peers to help you through these skills. So the idea with these skills is that hopefully you've seen them before in some way, shape, or form in the past, with this being Algebra 2. Now, I taught middle school and Algebra 1 before this, so I know that I've covered what we're doing today and actually both of those courses. So the idea is that, again, just a quick refresher, make sure that we're looking at these problems the same way and that we don't have any confusion, because these are important. We want to make sure that we're doing them correctly. And even if we have done them, let's say, a year, 2, 3 years ago, it's not always going to be the easiest thing to remember right away. So with that being said, let's jump in. When we're solving equations, what I want us to think of is when we have an equal sign in an equation, I want us to think about that as a balanced seesaw. So perfect balance. What that means is that whatever is on each side of this equation is going to have the same weight. It's going to lead to a balance. Now we see something up top here that looks maybe not exactly like what we would expect. I'm going to make my pen a little bit bigger. Hopefully that'll help. So we don't expect this because there's an elephant. And this elephant is definitely going to weigh more than the mouse down here. So instead of the balance looking like this, we'd actually expect that our balance would be down the other way. And if this elephant is on here and the mouse is on the other side, maybe that mouse would get launched, right? That seesaw is definitely going up. The elephant's going to weigh a lot more. But either way, what we're going to see is that the elephant does not equal the mouse. And because of that, we're not going to have any sort of balance if we have an elephant on one side and a mouse on the other. Now I'm going to show off my really impressive drawing skills here for you. So this is my elephant. I'll give him a tail, a little head, trunk, and there's an ear form. So wonderful, beautiful, impressive elephant is on the right side. And on the other side, we have our mouse. So this guy's a little bit smaller. And we know that this isn't balanced. But the point of algebra and solving these equations is that there is a way that we can balance this out using just elephants and mice. So if our goal is to, let's say, balance, what I want you to do now is pause the video and think about what can we do to this seesaw here to get balance. So a lot of different ideas, and during class time, we're going to be talking about this quite a bit more. But for now, the main way that we can do this is there is a lot of weight here. So this side is heavy, and there is not much weight here. This side is light. So in order to balance this, we can add weight or add mice to the side that's light. And eventually, if we put enough of these mice on this side, we should get the weight of an elephant. So bonus extra credit question here is how many mice equal, I can write, I promise. How many mice equal an elephant? So I would guess elephant weighing multiple 100 pounds and a mice weighing maybe a pound or 2. It would take quite a few mice. But the idea is that we can use algebra to solve for exactly how many mice are going to equal the weight of that elephant there. So that's the concept today. So I think a lot of times when we're solving equations, we kind of get lost on the idea of what are we actually doing and why are we doing it. So our whole goal for today is balance. So we're trying to balance out the seesaw. We're going to be trying to balance out some equations later on. So an example of this may be using numbers. On one side here, let's say we put 9. what we're going to see is automatically right away that 9 is getting weighed down. It's heavier because there is nothing over here. Now, if I put something like 2, it's still unbalanced, right? 9 is still heavier than 2. But what about 20? We're going to see that that is going to be heavier. So when we're solving equations, what we're solving for is equality or equal weight. So 9 equals 9. And we're going to be doing a whole lot of math with some variables for this. And basically the only thing that it's going to boil down to is, does 9 equal 9? Is our equation balanced? And I really like this concept because if you do it correctly and you understand the balance, there's no reason you should ever get anything wrong. Once you solve for a variable, if you plug it back in, you should get an answer something like 6 equals 6. So if you solve correctly, you'll see balance. And that's our idea. All right. So we're going to go back here. We're going to go to our first example, the first type of, let's say, question that we could see. This will be on page 2 of your notes here. So go in, we're going to do some writing. So you're going to see, I know this is our first lesson, a very similar structure for me every time. We're going to get a definition, we're going to get some steps, and then we're going to go through some example problems. So our definition for today, and you can write this down too if you have notes on the side, is coefficient. So coefficient, what this is going to be is a number or quantity. And I apologize, I know there's a little bit of lag with the writing. So a number or quantity that we multiply our variable by. So let's say we had an equation, and I'll do this in a different color on the bottom. Something like 2x equals 7. What we're going to see is that our 2 is our coefficient. The reason why we're focusing on this as a vocab word today is because we're going to need to have a pretty fluid knowledge and a solid grasp of what a coefficient is in order to solve an equation. So in this example here, this would be saying like 2 elephants equals 7 mice, right? So we're trying to figure out our variable here. So coefficient and next to the variable. All right, so your first job is to first eliminate the constant. And second, you want to isolate the variable. Again, apologies for the lag again. Isolate the variable using the inverse operation. So a lot of math words, a lot of vocab here. I know it's our first one back. So just to recap here, constant, that's just a number. So number not attached to a variable is just a number by itself. Second, isolate the variable. So we talked about that. That would be the variable. So the letter, we'll say. So x, y, whatever it might be is a variable. Inverse operation is very simply means opposite. So for example, if we had addition, it's not writing for me. There we go. The opposite of addition would be subtraction, or the inverse of addition is subtraction. If we had multiplication, the inverse of multiplication is division. Okay, so these go back and forth. The inverse of division is multiplication. The inverse or opposite of subtraction is addition. So that's gonna help us out here. All right, so let's get to work. Let's do this. So the first thing that I always do, I call this my algebra line. I like to keep organized, and I think of it as my seesaw. So on the left side of my algebra line is one side of the seesaw. On the right side of my algebra line is the other side of the seesaw. Because we have an equal sign here, we know that we have a balanced seesaw, so we have to figure this out. We have to figure out how many of those mice are we going to stack up to equal the elephant. So step number 1, it says first eliminate the constant. Well, let's see. I have a variable and I have a constant on the left, and it tells me to eliminate, so let's do that. So minus 12 minus 12. And you'll notice I use the inverse operation here. I had addition, the opposite of that is subtraction. Okay, let's see if this worked. Positive 12 minus 12 is 0. 26 minus 12 gives me, it's okay if you have to use a calculator for that, I know it's been a minute, it's 14. And this is my new seesaw. On one side I have nothing, and on the other side I have 14. We know that can't be right. We forgot to bring down our variable. It's still there. So we have x plus 0 equals 14. Or x plus nothing, right, equals 14. So we're left with our solution, our answer here is x equals 14. So we need 14 more of those mice to balance out that elephant. And that's our final answer. So our goal for this is just to get the variable alone on one side of the seesaw. So we want to get one elephant on one side, we want a nice balance on the other side. So our one elephant equals 14 mice. So one thing on one side, one thing on the other. And if we're going to take a look at this again, a nice balance works for us here. All right, so slightly more in-depth example coming for this one. Again, we have a constant. So we're going to follow step 1. And we are going to eliminate that constant using the inverse operation. So positive, let's use that subtraction sign. Minus 17, minus 17. Another important thing to note here is that we have to keep our balance. So a big idea behind balance is that we do the same thing to both sides. So let's do this here. 17 minus 17 is 0. 30 minus 17 is 13. And just like before, we have to bring down that 5x. So we have 5x plus 0, or plus nothing, just gives us 13. And we are one step away. We want just one elephant on the left side, but we have 5 of them. So one more time, we have to use the inverse operation. So 5 times x, the opposite of times, is going to be division. So let's divide by 5, divide by 5. So our final answer here, we're going to get x equals 13 over 5. And I am okay with that. If you want to leave it just like 13 over 5, that does not bother me in the slightest. You'll see a lot of college math, not simplifying is not a big deal. If you had to, 13 divided by 5 is going to give you, what, 2.6, or as a mixed number, it'd be 2 3/5. But I am not afraid of improper fractions. So if that's easier for you, leave it like that. We're good to go. So that's the idea for our first step for solving equations. We're seeing a very straightforward example here, some really clear balance, some really clear steps, and hopefully we're feeling pretty good about this. Now, where it gets harder, and I think a lot of people would probably agree with this, is we are introducing some fractions. So now we're going to try doing these same steps with everybody's favorite concept in math, fractions. So first, another quick definition. Reciprocal is going to be the word. And the definition of reciprocal is when we multiply by the reciprocal, or when we multiply by this, we get 1. Now, as a statement by itself, maybe that doesn't make a whole lot of sense, but let's go over some examples. So if we have, let's say, I don't know, 2 over 5. We need to multiply 2 over 5 by its reciprocal in order to get 1. So that's our goal. We want to get 1 as our answer. So pause the video here, think about it for a minute. What can we multiply 2 over 5 by? That's going to give us a value of 1. So if you came back from that, what we're going to see is actually just, and I know a lot of people think about this, if you've seen like KCF as an acronym before for solving math problems, it's the flip. So reciprocal, if you want to write some shorthand under there to remember it, we flip. So 5 over 2 is the reciprocal of 2 over 5. Now let's try this out. Say, hey, Mr. Rudin, you said that this is going to equal 1. It equals 10 over 10. You lied to me. Well, what's 10 divided by 10? It gives us 1. So no matter what the number is, if we flip the numerator and denominator, it will always give us that reciprocal. So a couple of quick examples here. What if we had 3 over 4? What is our reciprocal of 3 over 4? Again, we flip it. 4 over 3. What about something a little bit harder? 7. Just the number 7. Well, the reciprocal of 7, just the number, think about it. If there is no denominator, if it's hiding, that's an inaccurate statement. There is a denominator. The denominator is just 1. That's this right there. So 7 is actually just 7 over 1, so we can still flip that. It's 1 over 7. So if you're ever in a situation you're like, gosh, I can't find the reciprocal, there's no denominator, there is a denominator. It's hiding, it's just 1. Okay? So this is going to help us out. So first, just like before, if there's anything else on that side of the seesaw, we want the elephant by itself, so we got to eliminate any of those constants. So numbers by themselves, we take those away. That way the variable has an entire side of the seesaw to itself. And then next, just that final step here is multiply by the reciprocal to solve. Okay, so applying these steps pretty directly right here. Again, I like organization, really important to not making simple mistakes on these questions. Eliminate the constant, and I'm just going to draw this off to the side again so I don't forget some of my inverse operations. So we have subtraction, okay, the inverse of subtraction, addition. Okay, so I'm going to add 6 to both sides. Again, I have to do the same thing to both sides to keep my balance here. So negative 6 and positive 6, not going to be 12, it's going to be 0. And then 5 plus 6 is 11. And if you're like, Mr. Rudin, 6 and 6 are 12, just a quick side note here. If we start off at negative 6, and we make a positive 6 jump to the right, we're going to end up at 0. And I'm going to plug in my laptop quickly, so if you want to fast forward through this part, that is okay. All right, so moving on. So this leaves us with, again, not 0 and 11. We can't forget about that 1/3 x. So we have 1/3 x plus 0 equals 11, or just 1 over 3 times x equals 11. So you notice how I read that out. It's not 1 over 3x, it's 1 over 3 times x. Okay, so I'm multiplying 1 over 3 by x. The inverse is division, or I can go back to my steps and say, okay, I got to multiply by the reciprocal. All right, so I'm going to take this whole left side, and I'm going to multiply it by 3 over 1. And then I'm going to take my whole right side, and I'm also going to multiply that by 3 over 1. And again, this isn't 11 with nothing under it, it's 11 with an invisible 1 right there. All right, so left side, actually instead of that x, I'm going to use a little multiplication sign. So I'm just saying that we're multiplying, that's all. So 3 times 3 is 3, 1 times 3 is 3, 3 over 3x equals 3 times 11 is 33 over 1. All right, so we're about done here. Just a quick last simplification step. 3 divided by 3 is 1, so we're just left with x. 33 divided by 1 is just 33, so we're left with 33. Okay, so that's our answer. So things that we did, first, we eliminated the constant, so I'll label this as step 1. And then step number 2, right here, we multiplied by the reciprocal. We took 1 over 3 and we flipped it. All right, so we're going to leave it at that for this note. Again, just know whenever we're seeing fractions, if we see a fraction, think reciprocal right away. Again, if we flip and multiply, it's totally good, but just make sure steps got to go in order. So before we multiply by the reciprocal, we do need to move this 6 over to the other side first. Okay, and again, balanced. We're going to see perfect balance on both sides. If we do one thing to one side, we do it to the other. We do one thing to one side, we do it to the other. And think about it like your balance seesaw again. If it's balanced and we start adding weight to one side without adding weight to the other side, we're going to get unbalanced very quickly. All right, last concept for today. We're going to see some parentheses. So last definition, I'm going to write it in, is distributive property. And what the distributive property is if we multiply group, we'll get the same answer as if we multiply the parts and add them. So the big idea here is if we see something like, I don't know, 3 times 2 plus 5, if we multiply the group, that's 2 plus 5, that would be what, 3 times 7, and we'll get 21. It's the same as if we multiply the parts. So if we were to do 3 times 2 would give us 6, and 3 times 5 to give us 15. Okay, add those up both ways. We're getting 21. So I'll do one more example off to the side so we can see it. So I'll have something like, let's say 2 times 3, let's make it more tricky, minus 1. So 2 different ways to do this. Up top, you can choose, want to simplify the inside first, that works. 2 times 2 is going to give us 4, and then here, we're going to get 6 minus 2 will also give us 4. The important thing to note here is that signs are attached. So this is not 6 plus 2. This is a minus 1, so it's going to be a minus 2 right there. All right, so first, distribute to eliminate the parentheses, and then next, solve using any method of your choice. So basically, once we eliminate our parentheses, we're good to go. It's just like the previous examples. So for this one here, distribute 3 times x plus 15 equals 27. And now we're back to that first example we went over. So we're eliminating constants, we're dividing, we're getting a number that is x equals. So the big thing here is I eliminated my parentheses because I multiplied by the number on the outside. So quickly going through this here, minus 15, again, same thing to both sides, keeping balance. And I do want to show this, I'm proving that I have balance. And I know it seems silly on these first easier, shorter examples, but when it gets harder, keeping your organization is going to be key. And again, 3 times x, the opposite of multiplying here, is going to be our division. All right, so x equals 4. We're good to go here. Just as a side note for these ones, and we'll do it for number 2 here. If you're like, I don't want to distribute, I hate multiplying by the numbers on the inside. If you just have the quantity here, so 7y plus 2, what we're going to see is that, again, divide and divide, we're allowed to do this. So this is 7 times y plus 2. The inverse of multiplication is division. So this works. On the left side, we have y plus 2, and on the right, we have 3. So totally up to you how you want to solve these. If you want to draw the arrows in to distribute, or if you want to divide on both sides, that is okay. I just want to say this one more time for clarity. We're only allowed to divide on both sides if this is all that's there. So if there were more constants next to this, we wouldn't be allowed to do that. But because it's just the parentheses on the left side, we're good to go. So last step, finish this one up, get y equals 1. All right, so this should cover the 3 main types of problems that you're going to see on practice today. So in terms of, we have some fractions, we have some parentheses, and we just want to make sure no matter what we are doing, we are keeping balanced. So think back to that seesaw, think back to the balance, and that will be a good guide for you today.